Kids, welcome back. I know, I'm so excited that you came back. It's very exciting. So here's where we left off. We were going from here to here, and we're trying to figure out how to connect which one makes the most sense. So remember, this is x and this is t. So let's just talk, and let's make this sure that it makes sense, because physics needs to make sense. All right, the linear one, okay? Well, the linear one means for each time interval, I'm going up the same distance. Well, for each time interval, I'm going up the same distance. What am I doing? I'm going at a constant speed. Oh, A to B. Oh, wait, I'm speeding up. Oh, I don't want it to be a line because I'm not moving at a constant speed. Does that make sense? Okay, oh yeah, hopefully that does. Well, okay, so what was I doing? Oh, I'm speeding up. Well, if I'm speeding up, that means in each time interval, I'm going to travel a bigger distance. Oh, so if I put some time intervals here, and if you look, do we see this one is speeding up? Oh my gosh. So let's draw that graph, okay? Again, yes, it is a curve. The curve is curving up, but make sure you understand why, okay? You're not just going to memorize things. You've got to understand it. All right, so there we go. Next, going from B to C. Oh, going from B to C. Look, I have dots, just like I did over here. So I need to connect the dots that make sense. Okay, let's see, B to C, I was moving forward, slowing down. Well, it's not this one, because that was constant speed, because each time interval I go the same distance. It's not this blue one, because I was getting a further distance. That means I'm speeding up. Oh my gosh, look at this one. Ready? Do we see, oh, that first time interval. Look at that first time interval. Big, and then it's getting smaller, it's getting smaller, it's getting smaller. Oh, I need that shape. There's that shape. Okay? So far, so good. All right, ready? Now I'm moving backwards. All right, well, let's kind of do this one. So here's a dot and here's a dot because I'm moving backwards. Remember, we have our three things. You could go here, you could go here, or you could go here to get there if this is my x versus t. Those are the only three ways I could get from this dot to this dot. That's it. So then we have to think about, well, which one is it? So if I am going backwards at the beginning, I'm moving backwards, speeding up. All right, so let's think. Well, that one was our constant speed one because same distance, same time interval. Let's see, this one, the other way you can think of it is, and hopefully you're starting to think about this, if you think about slope. Do you see how like the slope stays the same the whole time? Hey, look at this one. Ooh, that slope's getting steeper. Ooh, hey, that is speeding up. Where this slope, oh yeah, that slope's getting less steep. That would be slowing down. So I want speeding up. There we go. And then the last part, going backwards, slowing down. There we go. Okay. Hey, physics should make sense. Okay. Next, now we're going to do our V versus T graph. So again, we're going to start with our dots. Okay. So this was a position versus time graph. So the graph, what does the graph tell you? Well, it tells you position. What else does the graph tell you? Well, the graph tells you velocity. How does it tell you that? Well, you look at the slope. The slope is going to tell you, oh, look, positive slope, moving forward. Getting steeper, speeding up. Positive slope, moving forward. Getting less steep, slowing down. Hopefully that makes sense. All right, let's do our V versus T. Okay, dots first. What's my speed here? Oh, yeah, nothing. All right, B, which way am I moving? Well, I'm moving forward. All right, I have positive velocity, I have negative velocity. Which one should I use to represent moving forward? Okay, let's use positive. That makes more sense. So that means at point B, I am going to be here someplace. Everybody good? Okay. Point C. Oh yeah, I stopped again. I got to have a dot there. All right, point B. Oh, now I'm moving backwards. Got to be down here. Why? Because the negative tells me direction. Okay, I'm moving backwards. And then point A, hey, I go back to here. Oh, interesting. Very good, very good. All right, now again, I need to connect my lines. Now, remember, if I want to connect my lines, if I just make this a V now, I have three choices, okay? But, okay, remember, and hopefully we got this from our Tracking the Force lab, that the net force, actually let's do it this way, acceleration depends on the net force. Not only the direction, but the size of it depends on that. Well, going from A to B the whole way down, that's my force diagram, okay? Well, you know what? If my force diagram is not changing, that means my net force is not changing. If my net force is not changing, that means my acceleration is not changing. Well, then let's do our A versus T graph first, okay? At the first, if you go from A to B, oh, my acceleration the whole time is positive. How do I show that? Oh, all right. If you look, going from B to C, the whole time, my acceleration points backwards the whole time. And it's constant, okay? Oh, so that means like this. Then, going from C to B, hey, wait. B to C, my net force points this way. C to B, my net force still points that way. Well, that means that my acceleration has to stay the same. So let's be clear, kiddos. We're going to be clear with this. Ready? Okay. Remember, acceleration this is our stuff with our fingers. Okay. If I have negative acceleration, I am accelerating backwards. Well, if I'm accelerating backwards, what happens if I'm moving this way? If I'm moving forward? If I'm moving forward and accelerating backwards, I'm slowing down. If I'm moving backwards and I'm moving backwards, what am I doing? I'm speeding up. So remember, acceleration just doesn't tell us which way we're going. It just tells us which way our velocity is changing. All right, and then from B to A, oh, that's going to be the same acceleration we had before. So I have this graph. All right, so we got our A versus T. But then you might ask, well, what the heck? Why did I do this before this? Well, here's why. Okay, slope here, meters, and then seconds. Hey, guess what? Meters per second is velocity. Slope tells me velocity, okay? Here, slope, meters per second. Oh, slope, meters per second is acceleration. Slope of a velocity versus time graph is acceleration. You're not memorizing, you're just looking at units, okay? Oh, so what is my acceleration here? Oh, it was positive and it's constant. If it's positive and constant, that means it's a line. What is it here? Negative and constant. It's a line. Negative and constant. Line with the same slope. Positive and constant. Boom. All right, hopefully we're good. And then there's a couple questions at the bottom asking you about C. Use your brain. Don't memorize. You should be able to answer those as well. All right. Hopefully you had as much fun as I did. Bye, kids.